Unit 10, Exponential Equations, Retake Review. First question, write a rule for the nth term of the geometric sequence. If you guys will remember, you were given this formula, and the formula for the rule was a sub n is equal to a sub 1 times r, right, your ratio, whatever you're multiplying by each time, to the power of n minus 1. First value, right, a sub 1 just means our first value. That should be super simple. That, in this case, is going to be 0.04. All right, now we got to figure out the r value, and whatever it is, it's going to be to the power of n minus 1. Okay, the r value is whatever we are multiplying by to get from one term to the next. So from 0.04 to 0.32. If you're not sure exactly what that number is, you can always divide and work backwards. So I'm going to take that 0.32 and I'm going to divide by 0.04, and this gives me 8. So I know that 8 is what I'm multiplying by each time. And sure enough, if you check in your calculator, we are multiplying by 8 each time to get to the next term. And that is our rule. Okay, for question 2, what is the initial amount of the exponential function shown in the table? All right, guys, the initial amount is always happening when x is 0. So in that table, since you do see the x value of 0, your initial amount is simply 4, right? The number that's the y value when x is 0. Okay, on the next one, we are looking at question 3, and it says write a function to represent the relationship in the table. I would definitely use my calculator for this. That way there's very little chance for error. Just a quick reminder of the steps. You're going to go to Stat Edit, and you're going to type in these numbers. Remember, L1 is X, and L2, you put the Y's. All right, Stat Edit. Once you've typed in those numbers, you're going to go to Stat again. You're going to click over to Calc. And because this is an exponential unit, right, we are going to choose option 0, which says exp reg. Okay? I'll put a video at the end of the review that shows you the exact calculator steps to use to put in the L1 and L2 to do the regression. But I'm going to go ahead and tell you that when you do use your calculator for this, you get the equation. The formula we're using, right, is y equals a times b to the power of x. Your calculator tells us that the a value is 0.6 and tells us that the b value is 5, all right, to the power of x. Again, I got these two values, the 0.6 and the 5, from the calculator. Question 4 asks us, what is the growth or decay factor of the exponential function shown in the table? And all we got to do there, guys, is figure out how is it growing. Please remember that exponential functions, you multiply, get to the next y value. We can kind of ignore the x's because they're just increasing by 1 each time. So to get from 4 to 12, what do I multiply by? Hopefully you came up with the number 3, and I think that's correct. Let's check the next one. Is 12 times 3 36? Yes, it is. And we keep going, and that pattern of multiplying by 3 does continue. So our growth factor is just 3. I don't know if y'all noticed, but question 2 and question 4 had the same table. So if you did want to use Stat Edit and get an equation for that, remember the a value is the initial amount, which would be the answer to the first problem, problem 2, and the b value is your growth factor, which would be the answer to problem number 4. All right. Problem 5, suppose a radioactive substance loses half its remaining mass each day. Write an equation that can be used to determine how much of a 58-gram sample will remain after X days. Keep in mind, the formula that we're using here is y equals a times b to the x. A is your initial amount, and we started with a 58-gram sample, so I'm going to use 58. The b value is our growth or our decay rate. This particular example is decaying because it tells us it loses half. So my b value is just half. This was one of the most missed questions on the exponential unit test because a lot of y'all wanted to choose -1/2. And for these problems, guys, you're just using whatever it tells you in the word problem. Like if it had said doubles, you would just use a 2. You wouldn't try and think about the sign, the positive or the negative. Just use whatever number it gives you. And again, to the power of x. We're done. All right. Problem 6, Patrick bought a car for $38,000. The car is depreciating at a rate of 8% per year. What will be the approximate value of the car after 6 years? Now this time we actually got a percentage, which means we're using this formula, y equals a parentheses 1 plus or minus, you're going to have to choose, r to the power of x. Okay, really quickly, remember that 8% we cannot use as is. We always have to move the decimal place twice. So we fill in a 0 that we were missing, and we're getting 0.08 for our R value. The the A value is still our initial amount. So the initial amount of this car was $38,000. We've still got that 1. Now I'm choosing to use a minus sign because of the word depreciating. So we're going to do a minus. Then we're going to use our rate, which we found was 0.08, to the power of 6 for 6 years. Okay, we're typing this in our calculator, 38,000, 1 minus 0.08 to the power of 6, and we get 23,041.49. Okay, so our answer to this problem would be $23,041.49. All right, next page, flip this over. All right. Question 7 says, answer parts A, B, and C using the equation f of x equals 1/3, parentheses 5, parentheses to the power of x. Remember, guys, the number in the front we consider A, the number inside we consider B. All right, so this says, is it exponential growth or decay? Remember that for this, we look at only the B value. And we look at just see, is it bigger than 1 or is it smaller than 1? So in this case, the B value is 5. So we get to say growth because B is greater than 1, right? Don't forget B is greater than 1. That's just a little side note. What is the y-intercept of this function? Well, the y-intercept is the A value, so it's 1/3. And the growth of the decay factor is the B value, so in this case, 5. All right, problem 8. An automotive specialist observes the value of a car over time. The table below shows the value after X years. What will the car be worth in 8 years? So for this, we are using our calculator. We have to, right? These numbers are not exactly perfect. So same steps as before, right? I'm just going to say stat edit this time, and it is still going to be an exponential regression. Okay, so when we did stat edit and we got our A and B values, our calculator gives us this formula. We've got y equals A is 23,021.92. I rounded up. The value for B is 0.7 and then a bunch of zeros, so I'm just going to use 0.7, and then we would just use to the power of x, right? This is the formula from our calculator. Now the question here is asking us, what will the car be worth in 8 years? So we're taking our equation here, and we are using 8 for our exponents. So we've still got the 0.7, now we're doing this to the power of 8. And we're going to type that in. Let's see here. We've got 23,021.92. And we get 1,327.17. All right, so about $1,327.17. All right, questions 9 and 10, we are using this graph to answer. Let's go ahead and let's start with number 9. Number 9 is really just asking us about different parts and pieces of the actual graph here. Part A says the domain of the graph. Well, I've got the graph going left forever, and I've got the graph going right forever. So my domain is simply all real numbers. The range of the graph. Guys, this is really important. Even as my graph kind of goes on down here, I know that it looks like maybe it will actually, like I know that it looks like we're intercepting the y-axis, but we really actually never touch it. Remember, that was that new word we learned called an asymptote. There's an asymptote there, so we're never touching that 0 value, which means that my range has just got to be all the y's are greater than 0. Okay, if you put this or equal sign there, you're wrong. Okay, it can never be equal to 0. It's got to be greater than 0. All right, the y-intercept of the graph is simply 3. The equation of the asymptote is y equals 0, right? This is the equation, the dotted line that's not actually on the graph that our function will never touch. Okay, does it show exponential growth or decay? Well, we're looking at it from left to right like we read a book, and it is decreasing, so we know that it is decay. Okay? Question 10 says, which of the following could be the equation of the graph? This should be a pretty simple question because we know that the y-intercept is always our a value. And if that's our a value, then we're pretty much done here. It's got to be b because that's the only one that has a 3 in the front, right? Which does make sense that 1/4 inside is making the graph look like it does with the decay. All right, last but not least, before we finish, I'm going to go ahead and show you the exact steps that you would use with your calculator. Okay. All right, so my calculator here. All right, you can see that I'm just kind of on the home screen right now. I'm going to go into Stat, and I'm going to choose the first option, Edit. These numbers that are currently in here are the numbers for X and Y from problem number 3. All right, so all my X's are in L1 and all my Y's are in L2. Once you've got yours typed in, go ahead and click the Stat button again, but this time you're going to go over to Calc. So we're going to click Over, and we want exponential regression, which we're not really seeing right here. So we're going to scroll down until you see option 0. Okay, so exponential regression, hit Enter. And then you get to click Enter a couple of times until you actually do get your A value and B value in your formula. Now remember, the R's, like these two, are not part of your equation. They're just the correlation. Like it tells you that it's a perfect fit because it's 1. All right, so your formula for this, like we talked about, right, this is your A value. So it'd be 0.6, and then 5 would be in the parentheses, and to the power of X. All right, if you're not sure what I'm saying, go ahead and look at the answer to problem number 3. That's how it would be written. All right, guys, good luck on your retake.